Right, so I'm dressed in black. So you can see my head floating down here. Boom, boom. Alright, so um, this should have been yesterday's, but I'm trying to catch up. Alright, so this is, I think this is, what is this, the third one? The third one in algebraic proofs for GCSE maths. And this one was a really interesting one, easily done, but really poorly answered in the exam. So what I suggest you do is pause me and have a go at this. And as soon as you've finished and had an attempt, start me again. Oh God, a little tickly cough. All right. So, having a look at this one and what students did wrong. The first mistake, and these are mistakes, the first mistake to make. Um, and it is quite common. It says any integer that's greater than 1, prove that n squared minus n is never an odd number. So it must equal an even number. Well, that kind of makes the understanding of it a little bit nicer. So n squared minus n. So what will some students do is pick some numbers, 1, 2, and just substitute in. So if you substitute in, you got 1 squared minus 1. Well, that's 0. Let's forget that. Especially since this n is greater than 1. So we'll start with 2. 2 2s are 4. 4 minus 2. And this is the wrong way to go. The reason this is the wrong way to go is because you've got to prove. And in my previous videos, I've made it quite clear when it says proof, it must be an algebraic proof. This was a 2-mark question. And one thing I always do, if I look at a question, I'm kind of, I don't know, I can't really see it. I can't really see what it's going at. One of the things I do say to all my students is factorize a quadratic if you have a quadratic. So, don't substitute numbers in. If you've got a quadratic and you still can't see it, factorize it. And I'm hoping me factorising that there was quite simple. If not, I do have a video somewhere on factorising and I'll probably link it in. Okay, so now factorised it, and that's 1 mark. So how do I go about proving this? Now this is the correct thing to do. The second mistake students make is they think, oh, well, it says prove it's never an odd number. So what if I put in an even number? So an even number algebraically is 2n. So then we can go down, I'll substitute 2n in for n. But that causes really, 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 God, that tickles nasty. Right. That causes issues in terms of, well, I'm only looking for another 1 mark. But put that aside, put that analysis aside. This is too complex. We want to find the easiest way to do something. And what we can have a look at is what this actually means here. So what that means is we have 2 consecutive numbers. We know we've got 2 consecutive numbers, and now I will give an example with numbers. If we pick the number 10, so if n equals 10, we've got here 10 times 10 minus 1. So let's put it up here, n. This is n minus 1. So n minus 1 is 10 minus 1, which is 9. Is 90. So you've got 2 consecutive numbers. And one thing at this point you could write is an odd times an even is always even. Okay? Now at this point, if I wanted to, if it was a longer question, and they wanted me to prove that odd times an even is always even, they haven't asked me to prove that odd times an even is always even. What they've asked me is that n squared minus n is never an odd number. And by saying that you have consecutive numbers, even if you started with an odd number, I'm going to start with 9, it's going to be 9 times 8. So this is n. So minus 1, this time I started with an odd number. So 9 times 8 is still going to give you an even number, 72. This was really badly answered. Really, really badly answered in the exam. But I hope that gives you some kind of idea of what to do and what they expect from you. Okie dokie, that's that video done.